Hello students, welcome to Lab 2. Like our last lab, this lab will also be a little bit more freeform, as all labs kind of will be, and we're going to make our way through this list of items that would be helpful for you to know in your assignment, in your coding career, kind of in general, but especially for data analytics. So today's lab is going to follow from our lecture, and we're going to spend a little bit more time on the Dplyr verbs. From the last lab and lecture, you should already be familiar with select and filter. And as a reminder, select kind of chooses columns and filter chooses rows. And in the first one, we choose them depending on their name or other criteria that you might find out later on. And in filter, we select rows based on some logical operation. Is this value equal to something? But we can do any other logical operation, and we'll look at some of those other operations later on. In addition to these things, we're going to look at the other three main Dplyr verbs. Verbs meaning they do things to the data. You'll notice that select and filter alter the original data that you start with, and they change them. Mutate adds a column, and you can define how that new column is calculated. So however many rows your existing data set has, mutate adds one column and keeps the same number of rows. Summarize is similar to mutate, but as it implies, it summarizes your data in interesting ways. We'll look into it. And group by is kind of a different verb than the other ones. It modifies the behavior of all of the rest of these. And this is a little bit trickier to get your head around, but we'll spend some time with it and you guys will see how that works. In addition to that, we're going to look a little bit more deeply at logical operations. We looked at the double equals in the last lab, and we may have looked at one or two other ones over the course of our lecture and the in-class work, but today we'll kind of have a better sense of what those look like. In addition to that, we're going to look at conditional statements. For example, maybe if a value is lower than some number, we want R to return one value, and if it's not, if it's larger than that value, then we want it to do something else. That'll be if else. In addition to that, we'll also look at some summarizing functions. These are things like the mean, the sum, the median, the standard deviation, the count, the minimum, and the maximum. And then finally, although you probably already know this based on what we did in the last lab, we'll look at the fact that R can do basic arithmetic. So, terrific. Why don't we get started? So as not to waste your time, I've already created a new script called Lab 2. I've already saved it in a special folder called Lab 2. And these are the two libraries that you're going to need for today. The tidyverse, as always, and gapminder. And we're going to get our data from the gapminder library. A quick reminder, you only have to download libraries once, but you have to call them every time you want to use them. So if you haven't downloaded the gapminder library yet as you follow along in the lab, go ahead and install packages gapminder and then call library. So let's go ahead and load our data. We're going to do data assign gapminder. Gapminder is a data set that comes from, no surprise, a gapminder library. And why don't we look at what our data looks like using one of the functions that we learned last time, head. Okay, what do we have here? So we have country, we have continent, year, life expectancy, population, and GDP per capita. Okay, all super helpful things, all super interesting things to know. For now, why don't we go back to select and filter. Right? So let's take a look at our data. As you can see, there's about 1,700 observations, which, while not as big as some of our previous data sets, is still too large for us to kind of visually comprehend. So let's just do a quick refresher real quick on how to select columns and how to filter rows down. For the sake of this assignment, let's look at select and filter. Let's do country year, and maybe we just care about life expectancy. And only for countries in Asia. Great. So remember, anytime we start our data analysis, we start with the object. Remember, our object we can see right here, it's named data. And then we put a pipe. Remember, pipe means and then we do something to it. Okay, so let's start off first by selecting the columns that we need. So we're going to select country, year, and life expectancy. Note that I capitalized the E because it's capitalized here, and R is case sensitive. So if you don't, and you run it, it'll tell you life expectancy doesn't exist. So let's go back and capitalize that, and sure enough it works, and it's printed out to the console. Terrific. These are kind of the 3 countries that we're interested in. And in fact, now that I look at it, I realize that I can't really filter from here, because if I do that, actually, you know what? Let's actually only for Afghanistan. I'm going to make it easy for myself. Okay, so we started with data. We selected our country, year, and life expectancy. And now I want to filter down my rows to Afghanistan. Now a quick refresh. We want R to look in the country column, and if the value is equivalent to Afghanistan, we want it to keep the row, and if not, we want it to get rid of it. So let's go ahead and run that. And you'll notice that there are only 12 observations, right? One every 5-ish years, from 1952 to 2007, right? Once again, remember that it's just kind of printing out in the console, right? So let's go ahead and let's assign this to a temp object. Let's run that. And you'll notice 12 observations, 3 variables. That was just a quick refresher. Select and filter. We've used both of these tools before. We used them last week in the lab. We've probably used them in class a handful of times. And so we don't need to spend too much time on how to do that, right? So let's go back here real quick. Select, good, filter, good. Okay. When we look at life expectancy, we kind of see these numbers that range from 28 to almost 29 to about 44, right? These are in years, but you know, it may actually be more interesting to look at this in another sense. So for example, we might say, well, let's assume you finally get to almost 44. We'll consider that 100%. What percent was 30 or 28.8 in relation to 43.3? How close were you, right? Well, we kind of know what the formula to calculate a percent is, basically. We just need to divide all of these numbers by 43.8. So let's go ahead and do that. So let's start again with our new data set. I'm going to write in temp, and yep, this is the data set we care about. And we're going to do a pipe. And now we need some function that will give us a new column that we can calculate. And that function is called mutate. Mutate adds a new column. And the way it adds a new column is in 3 ways. 1, you need to name the column. So let's call this percentage life expectancy. That's part 1. You name it. That'll be the new name of the column. Then you put an equals because we're assigning data to that new column. And then on the right-hand side of the equal sign, we need to tell R how to calculate the data that's going to go there, or what data should go there. So we know that we need all of the values in this column to be divided by 43.8, right? Because if you divide 43.8 by 43.8, you'll get 1. And then you'll kind of get the proportion relative to this number for all the rest of them. So let's go ahead and do that. So we want to divide everything in life expectancy by 43.8. And you'll notice that I'm just using normal arithmetic right here. In fact, let's take a digression here real quick, even though we kind of covered this in the last lecture, that R can perform basically any type of addition, subtraction, division, any type of arithmetic that you're interested in, R can do. R is very good at this sort of thing, right? So terrific. Alrighty. So when we run this, before we run it, let's think about what we're expecting to see. I expect to see everything in these 3 columns to stay the same. And then I expect one more column called percentage life expectancy. And the values should range from, I don't know, about 60%, I'm guessing, to 1. So 0.6 to 1. So let's run it and see what we get. Yeah, sure enough, right? That's pretty much what we get. Perfect. And notice that there's a new column here. It didn't change any of the old data. Mutate doesn't change any of the old data unless you overwrite it. So for example, let's put this down here for a second. And one thing to notice, anytime I put a little hash symbol right here, a pound sign, that means anything that comes after the pound sign in this line is a comment. It's not code. So I'm just putting that there for safekeeping right now. If I did mutate and I put life expectancy, what would we expect to see? Would we expect to see a new column named the same thing? Or would it overwrite? Well, let's run it and see what we get. Ah, it overwrites it. That's right. So in R, you cannot have more than one column with the same name. You need to be able to uniquely identify your columns. So that's what mutate does. If you tell it to overwrite a column by writing the same column name that already exists, it will happily do that. But most of the time, we don't really want to do that. We want to preserve other data, our existing data. We want to keep it that way. Wonderful. Great. So let's write mutate adds a column name equals data. Right? Column name equals data. And let's put this back in temp. Now, just like mutate, if I rewrite this object to temp, then it'll overwrite it. So now temp looks like this. Remember that when we did it this way, when we just ran the selecting and filtering, temp looked like this. Now we run this, and temp looks different. So we've overwritten the old object. Terrific. So now we kind of have a good idea and understanding of how adding new columns works. And we can get a little bit of a better sense of something else too. So let's go back to our data real quick. Our full data set. Let's take a look at our full data set again. And we'll notice that there's like 1,700 observations here. Okay. Like I said, that's a lot of observations to look at, and I can't really make heads or tails of it just on my own. We need some way of easily summarizing the data that we have here. One easy way to do that is with the summarize function. And in fact, one of the things that we might want to know are averages. What is the mean? What is the median? And on average, roughly, how much does a given row vary from that average? So let's start with our original data set, right? You don't need to summarize things that are small. If there was only 3 or 4 observations, there'd be no sense in taking the average. You need the average for things that are really big. So we'll start with our data set. We'll say, okay, start with data, and then I want to summarize. And summarize is very similar to mutate in that you need to name a new column. So let's take the average of life expectancy. Life. So we'll call it average life. This is going to be the name of our new column. we need to assign data to this column. And now we need to tell R how to calculate that. So let's just take the simple average, the arithmetic mean, and let's run that and see what we get. Okay, interesting. Very interesting. As opposed to mutate, which kept all of our rows and kind of added a new row, what we've done instead here is collapse our entire data set into basically one row, one metric, right? And we'll look at extensions of this in a little bit. But for now, the key difference between summarize and mutate is that mutate keeps the number of rows in your existing data set, and summarize reduces the number of rows, right? It reduces it in kind of predictable ways. But for now, when we're just taking, we'll call this the global average, the average of all of the life expectancy values, that's what we get. And you'll notice that we can do all kinds of other summary functions. I know we're kind of running ahead a little bit here, but it's a good time to talk about this. Something else that might be interesting to know is max life expectancy. And sure enough, max is a function here. And you'll notice now that we added another column, and really our calculations only need to be separated by a comma within summarize or mutate. You don't need to call summarize or mutate again and again and again. You only have to do it once, and then everything you put inside of it will be calculated as long as you separate it by a comma. So we named two different columns, how to calculate them, and R summarized that for us. Super easy. So you can see that the max life expectancy, and I believe the years like 2007 probably was 82 years. The average life expectancy within that country. So whatever country had 82 years of life expectancy, that sounds like a nice country to live in. So let's go ahead and we'll say summarize reduces the rows to return your calculation. And in fact, now that we've done max, now that we've kind of explored max, why don't we go back here for a second and notice that I really don't like hard coding numbers. And if you find yourself in a situation where you're looking at your data and you're trying to extract specific numbers and you're typing those specific numbers into a function, you should find a better way to do that. So let's go back and let's look at this temp data. I'm going to run this part only, and then I'm going to look at temp and let's see what we got here, right? What's unique about calculating the percentage as a proportion of kind of the maximum value is that, well, actually there's a better way to calculate 43.8 in a way that we don't have to write out 43.8. So for example, let's say that I'm writing this code and 10 years from now someone comes and looks at it and there's no documentation as to why I put 43.8. They're not going to understand why I did that. Instead, if I said divide it by the max of life expectancy, and then let's take a look at temp, we get the same result, and now it kind of makes more logical sense to look at it, right? We kind of understand better what we were trying to accomplish with this. So terrific. So we've looked at mutate, we've looked at summarize, and now here comes the fun one, right? So far, and I'm not gonna, actually I'm gonna delete this right here, just in case. So temp, mutate, summarize. So we're getting pretty good at adding columns, at reducing the complexity of our data set. But, you know, actually when we look at our data, we realize that, well, actually there are many different continents and there are many different countries. And it may be that I want to know what the average value of life expectancy is for each country. Or what's the maximum life expectancy for each country. So let's kind of capitalize on what we've done with summary or summarize and go from there. So let's say we start with data again. We're going to say, and then, and we know at the end of the day, we're going to need to summarize again, right? At the end of the day, we're still going to need this life expectancy. That's what we're interested in. So we're going to say, okay, average life expectancy equals mean life expectancy. We've done that before. But we also know that we want one row for each continent. Let's say we're interested in the life expectancy by continent. So I'm going to say start with data, and then I want you to group by continent. And then I want you to summarize. So let's run that and let's see what we get. Okay. Whereas when we ran summarize on its own, we got one row and one column. We just collapsed everything down to the one metric we calculated. Or in this case, we did two metrics, so we got two columns. Here, we only have to tell it how to calculate the metric of interest once, but then we tell R, or in fact, first we tell R, I want you to calculate whatever comes next once for every group, right? So I don't just want the global average. I want the average life expectancy for Africa, Americas, Asia, Europe, and Oceania, right? And I want you to separate those out. So group by is a modifying function. Doesn't do anything on its own. It changes how subsequent functions work. Let's take this a little bit further here for a second. Because summarize, in fact, by plus filter. Summarize is not the only function that works with group by. All of the functions that we've covered so far work with group by. Select, well, select is kind of irrelevant, but filter, mutate, and summarize also work with group by. So let's take a look at what that looks like. Maybe I want to know for each country what was the maximum life expectancy that they had in this data set. So I'll say, okay, first off, let's print our data so we can kind of see what the column names are and kind of take a look at how our data is structured. Okay, so I want one row per country, and that row should be the row for that country that had the highest life expectancy in our data set. So we know we're going to start with data. And then, since I keep saying it, we're going to group by country, right? We want one row per every unique value of this variable. That's another way to think about it. How many unique continents are there in our data set? 5. So I want one row per, I want 5 rows. I want one row per continent. Here I want one row per country. And in fact, since we know we want to kind of get rid of rows selectively, we know that the function for that is filter. And let's go back to think about what I said. I said, I want the row where life expectancy is the highest for that country in this data set. So I'm going to start with life expectancy. And remember, in filter, we need to do logical comparisons, double equals. And let's think what summary function would get the biggest value. That's right, max. So when we run this, let's see what we get. And sure enough, kind of unsurprisingly, since countries' life expectancy goes up over time, for most of these are going to be 2007. But you'll notice we have one row per country, which is pretty cool, right? It did this operation individually for every single country. That's kind of the power of group by, right? One last thing, group by plus mutate. Let's take this data and let's say I want for every country, I want you to put the average life expectancy for that continent. And I just want you to add that as a new column. So for all countries in Asia, and in fact, why don't we do for all countries in Asia in this year, what was the average? So this will be a little bit more complicated because we're not just grouping by one variable, we're grouping by two. So let's start that. And actually, why don't we do something a little simpler before we do that? Why don't we start with data, and then we're going to group by, continent, and year. And then why don't we just summarize for now? Average life expectancy. So before we run this, why don't we take a look at our code, see what it's doing here. First off, we're starting with our data. No surprise there. Next, we're grouping by two variables, right? So whereas when we did group by just one variable, we were saying for every unique value in this one variable. So, you know, for Asia, Oceania, America, Europe, and Africa, one row per that. When we have more than one variable, we're saying for every unique combination of these two things. So for example, all of our data is basically measured in these 5-year increments. We have measurements for all countries in 1952, 57, 62, 67. And so I want to say, okay, we'll take all of the countries, for example, that fall into Asia in 1952, and I want to take those averages. And it's going to do that for all of your continent times year combinations. So let's take a look. And sure enough, like a few things to notice. One, we have many fewer rows, right? But we have more than 12 rows. There's only 12 observations per country, but, we have 12 unique year values, and we have 5 continent values. So we ultimately have 60 rows. And in fact, why don't we just take a look at that so you can confirm that yourself, right? Africa, Americas, Asia, Europe, Oceania, right? Terrific. So group by is very powerful because it automates an enormous amount of work for you. If I ask you to tell me the averages of all of the countries for some certain time period, group by will get you there real quickly. Very powerful function. So great. So we've done select, which chooses columns. We've done filter, which takes down rows. We've done mutate, which adds a new column that you can calculate. We've done summarize, which collapses your data and obviously summarizes it for you. And we've done group by that modifies the behavior of these 3 functions, right? Between these 5 functions, you basically have 80% of the tools for data analysis that you need. Yes, you need a little bit more time to kind of learn some of these things, but in general, you've got a good foundation. So once you're comfortable with these things, spend some time with them, play around with group by, filter, mutate, and summarize, and you'll have a really good sense of how to use all of these tools in a really efficient way. In the meantime, the next thing that we should look at is logical operators. Some of these you're likely already familiar with because we've already used some of them, right? So these are double equals. 1 does not equal 2, for example, and so it'll tell you false. But 1 also does not equal 2, so this will tell you true. So the exclamation point equals means does not equal. Double equals means does equal. And then kind of the comparisons is for whoops, is 4 bigger than 2? You bet it is. Again, all of these will return logical statements, true or false. And is, and is 4 less than 2? It sure isn't, right? All of these are very helpful comparisons to make. Likewise, we can do greater than or equal to, and we can do less than or, I always forget that one. This one goes this way, right? So we can do greater than or equal to, less than or equal to or not equal to. These are all logical operators that we'll use. You've seen the use of the double equals, but we haven't really used these logical operators to do anything interesting. And now's a good time to kind of do that. So let's put together some of the things that we have learned. And let's just look at, for now, I want to filter down to Asia, countries in Asia. I'm going to say continent equals Asia. Terrific. Excuse me. And I think I only want to look at 2007. So again, you can put multiple conditions in filter, in mutate, and summarize, and they only need to be separated by a comma. So I'm going to say the year should equal 2007. I only want one observation per year. Okay, so there's about 33. Why don't we go ahead and select a simpler subset of our data so that it's easier to work with. And I want to keep country. I'm not going to bother keeping continent because they're all the same continent and we've already done our filtering at this point. I'm not going to keep year, but I will keep life expectancy. So these are our 2 variables. Next, I want to calculate a new column for the average life expectancy in 2007 in Asia. So we've done this already a few times, right? We're going to say the new column should be named average life expectancy, and the data I want you to assign to that column should come from the mean of life expectancy. And this should be the same value again and again and again. For all 33 rows, it'll be the same value. So let's go ahead and run that and see what we get. Yeah, pretty much. It's 70, right? That's the average. Okay, now I kind of want to know whether a given country's life expectancy is above or below that average, or equal to, right? And here's where our logical operators come in handy. So I'm going to say above life expectancy, above average life, equals, and here I kind of want one of 2 outcomes. I either want a 1 if that country's life expectancy is above the average, or I want a 0 if that country's life expectancy is below average. So we've worked with double equals before, and we get, true false statements, so we could use that. And in fact, why don't we start with that, right? Why don't we say, okay, is life expectancy greater than or equal to average life expectancy? Now, it can be a little confusing when you see an equal sign and then this, but remember, this is a logical operator. This is an assignment, right? So we're making a comparison here, and all this single equal sign does is tell it, put this data here, right? So you can ignore this equal sign. So let's run that and let's see what we get. Okay, we get a lot of true and false statements, which is fine. It's correct, right? Life expectancy here, yes, it is above the average. Here, yes, it is below the average. Yes, these 2 are above. These 2 are below. the calculation is correct, but there's not much that I can do with true false, right? I want something that's a little bit more human readable. And what we can use is a function called if else. So you'll notice when I typed in if else and I opened the parentheses, a little tooltip popped up with kind of 3 components to it. What is the test? What is a logical comparison? And luckily, we've already done a logical comparison, right? So in fact, why don't we just put it in there? And then what happens if your logical comparison returns true? What should I return? Well, I want you to tell me it's above average. And lastly, what should I return if it's false? Well, I want you to return below average. So let's take that and let's just put this in here. And for the ease of reading, I'm going to kind of put these 2 things down here. But line breaks are kind of irrelevant in R, so don't worry about starting a new line after a comma or something like that, right? So let's run that and let's see what we get. Sure enough, it took our true false values, and instead of just outputting raw true false values, it output this if this logical comparison was true, and it output this when the logical comparison was false. So this is kind of the power of if else. You can split your code to do different things if different criteria are met, right? This is kind of a very simple example, but still very helpful. You should find it very useful. We can use this column, the above average life, in visualization. For example, we might want to color some dots or some lines like purple and some other ones pink, right? To kind of distinguish from above average and below average life expectancy. So we've done comparisons, and in fact, we've implemented them in if else as well. We've also looked at a number of different summary functions, and I'll leave the rest of these summary functions for you to look up and see what they do, right? So we did mean, but sum is kind of just as simple to look up. Median, also relatively self-explanatory. The standard deviation as well. N just means count, right? So just count the number of rows in this given group combination. And then min, we haven't used, but we have used max, and min is kind of a good companion function for that. So let's take a look at our total data. Our total script. Let's go over what we did today. First off, as always, we loaded the tidyverse, and for our data today, we used the gapminder data. Then we loaded our data into an object called data. We summarized and refreshed how select and filter work. And then we discussed mutate. And mutate, remember, adds a new column, and it fills that with data that you tell it how to calculate, right? Then we did summarize, which, as its name implies, summarizes data based on the method that you tell it to summarize. So here we looked at the average and the maximum, but we could use all kinds of different summary functions here. Then we discussed kind of the more complicated or more nuanced function, which is group by, which, remember, it doesn't do anything on its own. It just tells R to do all subsequent analyses at that level of aggregation. So have one row. So when we do summarize, we know that we reduce the number of rows, but rather than reducing it all the way down, I want you to reduce it to 1 row per continent. Likewise, it works with many different functions. And here we said, I want 1 row per country. Here, we said, I want 1 row per every combination of continent and year, right? So group by, a little bit tricky to get your head around, but once you get your head around it, it opens up so much. You can look at many, many interesting different groupings and aggregations, and it'll be really important for you to kind of understand intuitively how that works. So make sure to give it a lot of practice. Then we looked at kind of some of the common logical operators. We've been using the double equals comparison, but today we also looked at the not equals the greater than, the less than, greater than or equal to, and less than or equal to. And then finally, we kind of did this nice, interesting script where we implemented a lot of what we already know how to use. And then we also looked at if-else. How do you do conditional things in R? How do you take two different paths depending on whether your data matches a given criterion or not? So in total, you should start to now have a good idea of the basic tools of data analysis. So in the last lab, we kind of went through the general workflow. You'll notice that for today's lab, we didn't really do any visualizations. That'll come in next week. But you have a much better idea of the tools that you can use to slice and dice your data, to focus on what's important, what's interesting. And that includes varying levels of aggregation. That includes looking at different ways of aggregating. And it also includes different logical operators, conditionally doing different things to your data depending on its relationship to something else, right? Again, just like last week, these functions really form the core of your tool set with data analysis. So I highly encourage you to spend a little bit of time with these tools. As I said last week, if you spend a little bit of time every day doing them, you'll be surprised at how quickly you kind of pick it up. A lot of this stuff, even though it's kind of built to be as intuitive as possible, it is going to take a little bit of an investment from you to kind of figure out how to do it. Now, when I sit down and I code, I know what to look for, and so I'm not going to run into a lot of the mistakes that I ran into when I started and that you're probably running into. I have an intuition for it in a way that you don't. But that's not to say that you can't have an intuition. You just got to put some time into it. So use this Gapminder data set, look at different interesting analytics that you might be interested in, filter the data in different ways, select different columns, mutate, add new columns, summarize, do all sorts of things like that on your own. And when it comes to your homework assignment, start early. Don't put it off until the end, and try and spread it out over the course of a couple days. So, as always, to summarize, we covered a lot of things today. Please spend a small amount of time every day doing analytics, and you'll get good at it shockingly quickly. And I hope you have a wonderful day.